All right. Continuing on in our little merry little journey, I've made some minor modifications, which I've written down over here since it's been like 4 hours or something, 5 hours. So, um, reading through the code, I realized that I don't actually need these long to short, short to long hash tables. I think I already mentioned this, but the idea of when I am adding, no, when I am doing my big for loop thing, passing all the arguments, um, when I add a flag value, right? When I add a flag value, um, I get the particular arg given one of the flags, right? Given the flag that we're sort of interested in, I get the argument struct, and then I set its value to be, the appropriate value as a string. Now, because of how I set it up, when I add a flag, that is, the short option gets the arg, and the long option also gets the same arg. Both the long option and the short option in the hash table point to the same address, map to the same address. So regardless of whether whether the our user's user provides the short or the long version, both of those keys in the hash table will then be mapped to the same argument. And therefore, if one of those keys sees a change in value because we add a flag value, the other will also see the same change because it's mapping to the same object. So I don't actually need any of this translation stuff that I thought I needed. So that's gone. So that's one thing. So that's all that says. Because the main flag hash table mapped to the same argument address, if a value is associated with one of the options, it's associated to both of the options. I do a bit of error checking, a bit more error checking, looking for duplicate arguments. So I don't think I had this before. In the add argument position here, so in adding an positional argument, this is like before the actual passing happens. If I try to get a particular arg name from the, in this case, the map of argument positions, positional arguments, I should probably name that differently. Anyway, if I try to get the arg name and it works, it's not null, it's a legitimate object, then that's a problem because that means I'm trying to add the same argument again, which I'm not going to allow, so I throw an error. And then similar idea over here. If I try to get the flag for the short option and the long option, and in either case, it's not null, it's a legit object, that means I'm trying to make the same thing twice, and so I should complain about that. That's what that is. Argument. Oh yeah, and then I had sort of a bit of a 50-50 on whether the value associated with the argument struct is on the heap or the stack. In some instances, I had it on the heap. Sometimes I had it on the stack. I have made a true lit constant. So in the cases where, for example, a flag is a Boolean type, its value will be that hash defined true literal, which is just a string to true. And basically everything, any value, any string value associated with an argument is going to be on the stack. It'll either be, from the argv array, or it will be this guy. If I search up like arg value like that, you can see it's either null, true lit, in the argv, or I print it. So in that sense, I'm always sort of using a static variable when I assign that value. So that's cool. So those are the main changes. And then the things I want to add or do is I kind of, after I stopped recording, I realized there was plenty of stuff I hadn't really tested. So I have to test, single option, but single dash, but multiple flags, right? Multiple Boolean flags specifically is how I'm setting it up. I need to check that, for example, if my user requests the long option of a value of an argument, like the value of a long flag, but their user gave the associated short flag in there when they were typing out the command line arguments, they both should map to the same thing. So I need to make sure that that all works. That'll make more sense when I actually do it. I wrote the same thing twice here. I need to do my freeing, right? Making sure everything's cool. And I need to add default values for particularly flag elements. I have Googled, apparently positional arguments can also have default values, in which case a user's user, my user's user, doesn't necessarily have to give the positional argument, but I'm deciding to scrap that for now because that seems like it might complicate things a little bit. So I'm just gonna, only flag values are allowed to have default values for now. So yeah. But yeah, let's just do all that now. So, we have I had a few tests and stuff going, but let's scrap some of this. And let's say we have a file name as a positional argument, and then we have something like what? Arg parser add flag parser. The short option is -a. The long option we'll just say is null for now, and the type is boolean, and its optional is false. Has to be there. I'll just do ABC. Okay. And then we have to say arg parser pass, given the parser argc and argv. I missed. And then I have to say print arg value, given the parser and the arg name, which is -a. Yes. -a, b, and c. And all of these should be set to true if I do the following. If I firstly compile, and then if I go a.out, the file name should be example.txt, and then a, b, c. These are Boolean flags, so I just have to set them. I have to just put them in there, and that should set them to true. Cool. And so each of them are set to true. If I put a and b, then in this case it becomes a null. So one extra thing I could do, I'm debating it, I think I will if I am bothered, is basically for flags that are not given by the user's user, so flags that are not given, like the -c for example was not given, set those flags to false. Those Boolean flags, for Boolean flags that are not given, set those flags to false. And yeah, and then for non-Boolean flags that are not given, if a default, I haven't done defaults yet, but if a default is provided, then use the default. Otherwise, maybe give a warning or something. I don't know. I don't think it should necessarily throw an error. Maybe I can say if optional, ignore, else give an error or something. I'm not sure. Something like that. That'll kind of be the workflow. But yeah, so -c is null. It's not strictly false. It's null because I never even touched the -c argument. But let's now try to test this other guy. So let's say instead of just -a, there's abracadabra, right? With a double dash. I should probably error check that. I always want one dash here, two dashes here. I've made a very big assumption there, but what can we do? So let's say, for example, I say clang, and I do a.out, and then I give the file name, and I give abracadabra, and I give -b and c together. So I've given all three flags, But here, I'm not asking for abracadabra. I'm asking for dash A, right? So what the user has given versus what the user is requesting is two different things, but they should map to the same information. Yeah, so dash A is set to true because abracadabra was set to true. And if I try it vice versa, if I ask for abracadabra and I only give dash A, then abracadabra, oh, I need to compile. Then abracadabra should be set to true. And it is. Because A was set to true and they map to the same thing. Good. It's got text to check if it's anything important. It is not. Okay, so that looks like it's kind of working. Do I want to do default values first or after? I'm just trying to think. I think default values, I can't imagine it's that hard. Something like string default value. Is this also on the stack? I have to think. I think it would be because, like, yeah, surely, right? I'm gonna assume it's on the stack because you would use string literals, right, to set your defaults. Like, why would you malloc? You wouldn't have to malloc the default. You know the default ahead of time. You don't have to do it at runtime or anything. So unless it's dumb, but yeah, I think default I will assume is on the stack, and the idea is when you want to pass, so we will ignore for positional arguments, but for flags, we can add a default. And I'll just say, wait, did I say flag? No, I meant default. Note that default value is allowed to be null. If you don't want a default value, that's fine. Why have I got an error? No, it's probably just, yeah, because I called it wrong, because it's an extra argument. So the way I think I will do this is arg default value equals default value, right? That's fine, that's it. That's the only extra addition, right? Because if it's null, then this is null, and that's fine. If it's not null, then this will be set to the default value. Okay, yeah, that's good. So now over here, so short option, long option, and then you have to give a default value. So like, let's say I have no default that I want to give. Null, null, null. The thing is, if it's a Boolean flag, the idea of having a default value is kind of dumb. Yeah, is it optional? And yeah, if it's a Boolean flag, wait, did I do this the wrong way around? Yes, I did. It should be this one first, and then the type, like that. Yeah, that. So let me just think. Sorry. Yeah, like a Boolean flag, the optional thing should be true. Right? Like for a Boolean flag specifically, like If it's a Boolean flag, then why would you make it that it has to be there every time? That doesn't make sense. So maybe I'll give a little warning at the start for adding a flag argument. Add flag. If type is equal to Boolean and optional is equal to false and not optional, I don't know if I necessarily want it to be a warning. Sorry, an error. I think a warning would suffice. Warning. Setting a Boolean flag as not optional renders the flag redundant, I think. I won't exit. I'll just put that in there because I don't know. I feel like I'm right, but I don't know. Yes, so all that happens, and that's fantastic. I'm able to give a default value. Here I will say arg default value is equal to null because, like I said, positional arguments don't have a default value, at least in my way of doing it. I don't know. It's just what I'm going to go with. And then over here, when I do the parser, what I have to do is I have to go through each flag argument, check the thingy, check the what? Check if it is, check the value. If it is null and a default is not null, set the value to be the default. And if I was smart, I would make like an iterable thing like I did last time for the integer hashes, for the hash sets that I was doing before. But I don't know if I want to do that this time around. I is less than the parser. The flag values should be the string. Is that what I called it? Flag values? Yeah, I did. Flag values, capacity. So I'm going through every single slot. If flag values, if the actual array at I, if it's null, or it's a tombstone, then we can just continue because nothing more to do there. Otherwise, you can say if, what can I say? I need to get the value. Otherwise, argument star arg is equal to parser flag values ht at I value. And that's a void star. That's a void star, so I cast that as an argument pointer. Like that. Fantastic stuff. I think this is right. Anyway, if arg value, if it doesn't exist, and default, nope, and arg default value does exist, then Yeah, if there's no arg value, okay, here's what I'll do. If there's no arg value and arg type is equal to boolean, then I'll say arg value is equal to the false literal. Not what? False. Okay. Then it's equal to the false literal is what I'm going to say. Else if there's no arg value and but they gave a default, then arg value is equal to arg value equals arg default value. This is static, I'm assuming. Is it static? Yeah, it has to be, because it's a string literal. They'll be chucking in a string literal. Or at least something that they made really early in the program, so it won't clear out anytime soon. Like, it will last the entirety of the program. There's no way. And so this is static, and this is static, so happy days. If there's no argval given, and you are an argval given, else if there's no arg value, and arg optional is false, if it's not optional, if it has to be there, then I think I can be like, hey, argument given is not optional. Optional. I should probably specify. Whoa, I shouldn't have done that. I should probably specify which argument. Fprintf. Oh, I have zero idea what argument it is, don't I? Do I? Yeah, I have no idea. Because I'm iterating through the hash table, not through the... Wait, which hash table am I iterating through? No, I should know the... Don't I? Yeah, the key. The key is the thing. Fprintf. Parser flag values ht I key. Give a tab maybe. Yeah. So if you don't give a value, there's no default, and you're up to here, and it wasn't set to optional, then you're in trouble. So hopefully with that, we should be able to populate all of the sort of non-given flags with defaults if available, and if default's not available and the flag is mandatory, we can raise an error. Or we can, report it. Okay, so hopefully that's pretty much done for that. And the last little bit is to free everything. So arg parser free. I'll just say this is for debugging. Given, I guess all I really made was the arg parser. So let me look at my structures. I have a bunch of hash tables. I have this pointer array thing. I have to free the argument. So I think I'm safe to just free the two hash tables just like that. Wait, did I not make a freeing thing for this? Oh my god. Oh, I did. Okay, I just forgot to publicize it. Shows you how much I care about memory management. Hash set free. I don't want to call it that actually. String hash table free. Fair enough. String hash table free given parser no, yes, that one. String hash table free given the parser's other hash table. I think it's this one, right? Nope. It's that one. That maps the argument to its position. So free those two guys. So that's those two fields done. Bang and bang. That one and that one. Back to free that one. So num position arguments tells me how many there are. So less than parser num position args plus I. I should be freeing the argument stuff. So these are both on the stack. That's going to be on the stack, I think, and that's on the stack. So I think I just have to free the actual argument thing that I malloc. So free parser positional arguments is the double array, right? So that's the array of pointers. So accessing a particular guy gives me that pointer, that frees that. So I'm freeing each argument structure within the array before I free the overall positional arguments array, and then I free this guy himself. And let me go, so at the end of all this, I say arg parser free given the parser, and we call it a night. All right, let us see. Let me clang. I should probably clang with -g so I don't forget. I missed. The string is not a string literal. Oh, is that a thing? I can't. I didn't know that. I can't f put s if it's a string literal, it throws a warning. Maybe I did know that. I don't know. How to print a non-string literal securely in C. What's like your... Okay. Oh, what? Okay, I'll use that then. F puts. But it's the other way around, right? You give the file pointer afterwards. How intriguing. Fine? Are we okay with that or what? Okay, sure. So I do that, and then I say, let me just make sure this runs. I messed up. Wait. What? Optional is false. Oh yeah, because I said that, right? It should, if it's a boolean, then you'd expect the optional to be true, and I didn't give enough positional arguments. So optional is true. Let me do that again. A dot out. My my thingy is example.txt. I'm going to say dash A, B, and C all together. And then we're going to see what happens. Oh no. So just to clarify, before I do this freeing, that should be fine. Okay, so something went wrong in the freeing, that's fair enough. Error for object that guy. Pointer being freed was never allocated. Okay, this could be very bad for me. I had a similar issue with my other hash table to do with resizing. Although I'm not sure if there'll be any resizing in here. In this case, I can confirm that. Last time I had this error from memory was because during the resizing, there was like a weird thing where, because I was using double pointers and I was trying to be clever, but like when I was resizing, I would like create a new hash table, right, to move the elements into, but like that address wasn't being returned back correctly, so I was still holding the old address and that had already been freed, so then trying to free it again was like a whole thing, something like that. If I use leaks, would that give me more information? I forget. Leaks, did I compile this already? Okay. Whoa, I didn't mean to do that. I don't want the news right now. Leaks, how do I use this again? At exit? I use this so much, I still forget. A dot out, and I'll just copy this across. Well, I mean, that's a good sign, but I feel like that's not. Set a breakpoint in malloc error break. That's cool. We might be here a while. How did I figure this out last time? Did I debug it? I probably would have put a pointer in it somewhere. Okay, let me probably try sanitizer real quick. Let me just see if that does anything. Let's try fsanitize undefined, I guess. Whoa, I don't think I've ever seen trace trap before. Okay, let me try address. There you go. All right, let's see. So we have a double free, which is kind of making me very nervous. There you go, yeah. Okay, so I'm fairly sure the reason would be because attempting a double free. Does that mean the freeing happens here once? Oh, it happened here specifically. Free the H. Okay, let me see. So it started over here, went over here, started over here, which involves freeing the flag values. Okay. Does it say the last time it was freed? Oh, it was freed here. So it was freed here in the same call. In this 345, 319, 233. It's repeated, right? Previously allocated here. Add flag, yeah, that makes sense. So wait, I don't know if I'm interpreting this wrong, but it's saying that it was freed, the resource that's being double freed. It was freed here, but then it's trying to free it here? Unless this is just saying where it was freed. But that doesn't make I don't know, this doesn't make a whole lot of sense to me. 345, 345, 319, 319, yeah, it's the same. String hash table free. Attempting to double free. Okay, I mean we can try to we can try debugging it properly. Let me just think. if I put a sanitizer and I try debugging, does dumb stuff happen? I think it's okay, right? I know if I put a sanitizer and try use leak, sometimes dumb things happen. I need to make a launch file. Sure. Thank you. Not a launch file, it's a tasks file? I forget which one is which. Maybe it is a launch file. Oh, I forgot how to do this. Wait, why is it not doing the nice things for me? I think it's this one. Enter a program name. It's that guy. Oh. Wait, normally the workspace folder is good. Okay, that should be good. Arguments, I have a few. My bad. Stop at entry, no. Okay, let's just try that, see if that works. I've compiled with a sanitizer. Why is this broken? What's wrong with that? Is it because I need to set like -i? I forgot, yeah, I need to do this. This is not a great way to do this, but too many quotes. And I won't bother with naming it different. You still complaining? You were fine 2 seconds ago. Oh, VS Code, VS Code. I think it's something about tasks, or it's one of these files. Must be. Whatever. Warning, this guy is newer than the module file. Really? Okay. So yeah, in that call, it breaks due to trying to double free. How intriguing. How easy is it for me to look at what's inside? 4 active elements. So this is for the flags, yes? Let me just think about my input. I have 4 active elements? Shouldn't I have 3? Just to clarify, this is for the flag values, yeah? I have 4 elements? Does that make sense? Hmm. Whoa, I didn't mean to click that. What did I just click? What? What about that? Okay. I really don't have to go through the whole program. If I can get away with just doing it. Whoops. If I could get away with just like doing it up to here. Anyway, I have my parser, which means I have my flag values. I have 4 active elements. I would have thought I only have 3 because I have 1, 2, and 3. Hang on. So 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 7, 8, 9. And in terms of when I actually, when I add to the table, that is the flag table in particular, I add to this guy when is parser flag values ever mentioned? So hash table add happens in add flag, which is where it's meant to be. Ah, wait, no, it is 4. It is 4. Of course it's 4, because 1, 2, 3, 4. No, I'm dumb. Sorry. 4 is correct, yeah. Yeah, of course it's 4. If I gave these long versions, it'd be double. 1, 2, 3, 4, 5, 6, yeah. Okay, so 4 is fine. Sorry, that was dumb of me. I do all this, which is... Oh, I get it. I know why. Of course, because this guy and this guy points to the same guy. Ooh, that's going to be annoying. Oh, I didn't think of that. Okay, I understand. Okay, so just to clarify, no, double free makes sense now. What was the gift of this code, which was they both point to the same thing and make my life easy, is now become the curse because I'm double freeing. If I do this and I run, sorry, if I do this and I run the whole thing again, the freeing happens, no worries. With the sanitizer, nothing. It's because, what did I call this? Address, what did I call it? Abracadabra, whatever, it's fine. It's because I have this, basically the structure, I didn't think about this properly, but the structure is like A maps to some argument, right, with the value. The address flag also maps that argument, and then B and C map to their own little arguments, right? The issue is, I iterate through all these elements in the hash table. That's what's happening, right? When I free, I iterate through all the values in the hash table, and I say, look, I have managed, I iterate through all the values and I free the value. I iterate through all the keys and I free all the values. So when I get to A, I free this guy. When I get to address, I try to free him again. That's a double free. Okay, so I need to think about how I'm actually going to free this properly. I didn't think about this. Something along the lines of, I either have to keep track of the addresses I free, which is really annoying. I'd rather not do that if I can help it. Or maybe the better option is one that I haven't thought of. I really don't have to I really don't have to have 2 copies of the same value. I don't want to have to do that just for the sake of this freeing, because there's definitely good ways to do this that don't involve things like that. Um, Something about only freeing the keys, maybe? Yeah, because it was a little bit silly of me to assume that I guess, yeah, it was a little bit sillier for me to put everything on the heap like that. Can I get away with putting everything on the stack so I don't have to free it so much? In the sense that, well, the issue, no, but the issue is when the function ends, that stuff gets, like, if I have a create argument function, like when I add an argument, like add flag, whatever, I create the argument struct there. So as soon as that function terminates, the whole thing wipes. So I have to put on the heap in order for it to persist. The reason I get away with the keys is because the keys are the actual arguments given at the very, very start as string literals. So those will persist through time, I think. Those will persist. As will the argv values, the values in the argv array, because those are the command line arguments. Those are also static. Are string literals static? Did I make that up? I don't actually know. Still thinking about this. Just to clarify, so that's true for the flags, but that's because there are two options like there are two versions for a flag which point to the same argument. What's the other thing? What's the other hash table I have? Map arguments to position. So that shouldn't have any problems because that maps to like a different value each time. And yeah, I'm malicking because of that whole that whole business. Okay, that's fine. There might be a thing where I have to provide a freeing function. All right. I guess, yeah, it's gonna have to be something like that. I have to keep a list of things I have freed, of values I have freed, and if I'm trying to free something else, I first check that list. Bit dead, but whatever. All right. For real, this will be the last one. This will be the last bit of this project, and then I should be done. Just gonna be fixing up how I free my stuff. Right now, I did this weird list stuff. I talked to Claude because I wasn't possessing the brain power to think for myself. And it said, do reference counting, you donkey. And I was like, oh yeah, reference counting makes sense. So what am I talking about? From the last thing, we talked about this issue of when we have our struct arg parser, it has a string hash table called flag values, which the keys are strings, right? The flags like dash or dash dash a or whatever, and then those strings map to arguments, map to arguments, which are the actual values of those flags, which is fun. But because flag value can have a long version with one dash can have a short version with one dash or a long version with two dashes, it made sense for those corresponding pairs, I guess, of flags to map to the same argument object, rather than pointing to two separate things that are kind of copies of each other. So, if this is the hash map, if this is one argument and this is my dash dash, then they will both point to here. And then the issue I was having was trying to free this structure, because how I was freeing it was I was going through all the keys and I was freeing all the items. But in instances where two keys point to the same item, I would free the same thing twice. So in order to fix that, what you're meant to do, or what you can do, is have a reference counter. I'm calling it num parents. I can probably call it something else. I can just call it reference. Whoa, I did not mean to do that. Sure. Why is it not? Okay, that works. We'll call it ref count. Okay, and the idea is if there is one person, one argument that links to that argument, there's one key that links to the argument, and the ref count will be set to 1. If there's 2, then the ref count will be set to 2, and those are kind of the two options in this particular use case. So what can I do? I can say, what can I say? I can say that when I add the argument, oh, sorry, for flag specifically. When I add the argument, if there's a short option, if a short option is provided, then arg ref count starts at 0. If a short option is provided, then increment it by 1. Arg ref count should increment. And if there's a long option, then arg ref count should increment again. So either there'll be 1 or there'll be 2, depending on how many options are given. And that's fantastic. And then from there, shouldn't need this commented stuff. When it's time to free, first things first, I don't need this list thing anymore. The freed arguments thing, don't need it. Don't need any of that. It's gone. Goodbye. I never loved you anyway. Don't need that. Don't need that. In fact, I think it's best just to get rid of this entire for loop because this whole thing is a bit dumb. Don't need that, don't need that. We're going to do this again. Okay. So, let's think about this nice and clean. In fact, before we move on, let me also say, I think I can do the similar thing here. Arg ref count, this is for the positional arguments. I guess it would be equal to 0, and then I'd increment it. How would it work for the positional arguments? I think I would do something. I think I can just make it equal to 1, to be honest, because there's one parent. Where do I use arg? Here. Fair enough. But that shouldn't be a big deal because the way I free this is different to how I free the hash table stuff. Anyway, okay. So if that's pretty good. And then what I want to do in my actual string hashing source code is when I initialize, I think what I want to do is I want to give a function pointer, which I've forgotten how to do this properly, but type def, you have to give the return type. I think you want to give the name value free function, and then you want to put a pointer somewhere here or here. I think it's this, and then you want to give the parameters. Is that it? Let me just check. How to type def a function pointer or whatever. I've googled this before. Yeah, pointer at the start, and then okay, cool. So I think given I don't actually know what I'm doing. Surely there has to be a parameter. Void star. something like this. And I think it'd be a good idea to have value-free function, maybe item-free function, maybe? Item-free function. Item-free. And the idea is the the init function will take in that guy. We'll take in a parameter. And so this will go like this. ht item free is equal to item free. And the idea is over here, when I want to free an item, instead of doing it like this, I say h free item free given the particular item. I think. And that should let me sort of control the functionality. So of course I have errors because I call hash table init twice, so they need to give functions for each of those. Map arg to position, so that's just a matter of, so I need to make two sort of functions. So void free integer given a void star item. In this case, I just want to cast it and then free. Well, in fact, I don't even have to do that. I can just say free. Can I just say free? Can I just use the free function? That's all I'm really doing, right? No, but it's I want to free the whole item. I want to free the whole item. Free int item. So I want to first free ht at I refers to ht. It refers to a particular string item pointer, I think. So yeah, we're gonna take in this. Yeah. Okay, hang on. So string ht item star is going to be the thing. We're going to free item value, and they're going to free the item itself. So that is the function that we're going to use for the map arg position. Ampersand? Because that's all we have to do for the map arg position hash table. We have to free the integer in the values field, and then we have to free the item itself. So in the free function, we're going to loop through all of the spots in the hash table, and if that is a non-null thing, we're going to call the function associated with the item free field, which for this hash function will be this function, and then we'll call and we'll free the integer and then free the actual item. So that should be fine. And then the other function I need is free the argument item given. Okay, in this case, the item's value is going to be an argument star. This is referring to the flag values hash table. I need to put brackets. This is referring to the flag values hash table. So the keys are strings on the stack, and the values are the argument stars, right? The values are the argument stars. So if we're going to say arg ref count minus minus, if arg ref count is now equal to 0, then we can free the argument. This is what this is all about. This is where the ref count comes in. Everything is on the stack, I think. So I think I can just free the argument, and then I can free the item. But notice that the decrement thing happens always, and the idea is when it hits 0, that means there is no more links. I'm confident that there's no more links that point to this particular argument, so I can happily free it, and there's not going to be any other keys that I get to in this hash table that also link to this argument. So that's the idea of ref counting. This is something that's done with like shared pointers in C++ as well. And then after that, we can free the items. So here, instead of using the free int item function, we use the free argument item function. And that should give us all of that, which means in my free function, I can indeed say string hash table free parser and then the flag values map instead of the map arg positions hash table. So we free that guy, we free that guy. Then we go through all these and we free all the positional arguments. And then we free the actual positional arguments array, and then we free the parser. So I think if I haven't done anything too crazy, we might get away with something here. Oops. What have I done? Oh yeah, this was the error one. Hang on. Oh, it's because I've completely forgotten how this works. Okay, wait, so I think it worked. Wait, that was a bit anticlimactic. I'll just say if h item free, if that's not a null pointer, then use it. Else, I'm making the assumption that there's nothing to free in the value, so I'm just going to free h at ht at I. If that makes sense. Maybe I'll write it differently. If it is null, then continue. That way I don't have to do all this nesting. If h item free, if the user gave an actual function, then do this. Otherwise, we'll just use the default. Okay. So yeah, if I go like leaks at exit, and then I go like no wait, I wanna do this properly. Let me look at this test. So optional is true. This is this. Optional is true. Optional is true. Okay. So if I say, I compiled already, right? So if I say a.out, and then my options are a or address, which is Boolean for some reason, and then I don't put b and I put -c. I did not prefer of course, because it's sorry. First let's say file.txt, and then we have all this. I should also say print arg value given the parser and given the file name. I want the file name argument, and it seems like it's all freed. It's a compile, of course. Cool, so that all works. And then if I try this, leaks at exit, and I go all of this. Cool. Seems to work. Nothing blew up in my face. Fantastic. I believe it's generally correct. I'm sure there are things that are wrong with it. I'm sure there are things that could be written much better. But for now, truly, I think I have probably something that's basically as clean as I'm probably going to get. Although this could probably be written a bit better. Actually, I'm looking through the amount of nesting alone is enough to think that I should probably break this into some functions. But that's more just cosmetic, more so than functionality. So I think I will probably stop there. I'll structure it in my own time, like properly with include directory and everything. But I think I'm good. Yeah. Okay. We'll probably see this library or whatever, this package make its appearance in other projects because there's a few like miniature console apps I want to build just for learning purposes. So this will probably rear its head a few times. So good. All right. Thank you.